And what we are going to do today, we are going to work on a review set for the final. Review for the final exam. For what? For Algebra 2. Okay, there will be 25 problems on the final. Number 1, problem 1 is about the GCF problem. What is the greatest common factor for multiple terms? Look for the GCF. So typical one will be like this. So please find the greatest common factor for 12ab squared and 6a squared b to the fifth, and then 3a to the third b squared. Okay, there are 3 monomials, and we are looking for the greatest common factor of all of the 3. How do we work on this problem? Number 1, we'll look at the coefficient part, the number part. Number 12, 6, and 3. What is the greatest common factor for the 3 numbers? So for 12, 6, and 3. And this one we know 12 equals 4 times 3. 6 equals 2 times 3. 3 equals 3 times 1. So they have a common part, 3. So the GCF equals 3. We have the 3 here. This is for the number part, coefficient. Then we'll look at, for all the 3 monomials, do they have any common variables? I see A in all of them. So A must be a common variable. So write down the A first. And then what do? I compare the 3 A's. Which one has the minimum, the smallest exponent or the power? So the first one, A, there is no number. That means A to the first. We don't need to write 1 here. And the second one, A to the second. Third is A to the third. I will use the smallest, the minimum exponent, so which will be the 1, but we don't have to write it. So common variable, 1 is A. The other common variable will be B. So now we look at what is the minimum exponent for B. B squared, B to the fifth, B squared. So 2, 5, 2, what is the minimum one? 2. Okay, done. This is the GCF for 3 monomials. Okay, so this is number 1 and number 2. So think of what we have done in chapter 6 after we learned how to look for the GCF, and then we moved on to the real factorization. So how do we factor a polynomial? A typical one, so number 2 will be a problem, factor a trinomial. Factor a trinomial. When the leading coefficient is 1, so we have x squared plus 5x minus 6. So let me use another one here. What do we have? We have a trinomial. The variable is x. And we want to factor it. How do we factor it? We want to break it down to a product. And we know if one trinomial can be factored, then it's going to be a product of 2 binomials. And in the 2 binomial, when the leading coefficient is 1 here, so how can we get x squared? It happens when we have x times x, we get x squared. So then we have x followed by a number times x followed by another number. So there were 2 binomial. And what are the 2 numbers here? So basically we are looking for 2 numbers. When we multiply those 2 numbers, it's backward of the FOIL rule. When we multiply the 2 number, we'll get number 6. So what 2 number? Their product is -6. And when we add those numbers, we'll get the coefficient of the middle term. So number plus another number, the sum is 5. So think of all the possibilities. There is no shortcut. We just quickly go through all the combinations, all the possibilities, and see what two numbers can satisfy those two conditions. And we know, so how can we get -6? 1 times 6, that's 6. One of them is going to be negative. Or 2 times 3, we'll get 6. One of them will be negative. And so we try all those add. Then I think, so 1 times 6, that's negative. 1 times 6, so -1. Let's see, -1 times 6 equals -6. So I satisfy the condition 1. Condition 2, when I plus those two numbers, -1 plus 6, what does this equal to? That equals 5. I found those two numbers. Product equals the number C here. Their sum equals the number B, the coefficient of the second term. Then just put the two numbers and the two binomials respectively. -1 represents -1. Plus 6 represents positive 6 here. Then done. So this will be a very typical way to factor a trinomial when the leading coefficient is 1. Okay, we only need two numbers. The other one will be still factor a trinomial when the leading coefficient is not 1. For example, we have 2a squared. So the variable can be any. 2a squared minus 3a plus 1. Okay, so here we have a number 2 here. So the leading coefficient is not 1 anymore. And if this trinomial can be factored, it's still going to be two binomial. To look for those two binomial, we need the 4 numbers. So the first two numbers, so sum A, sum number A followed by another number. So what are the two coefficients for the A? Their product has to be 2. So to get number 2, there is no shortcut. So this is the way I showed in class. I write this in a vertical way. Only 1 times 2, that's 2. Okay, so I put them as a column. 1 times 2, that's 2. And then I see what two numbers. So those two numbers, their product has to be 1. There is just one possibility. Actually 2. So 1 times 1 or -1 times -1. We got the positive 1. So 1 is 1. 1 times 1 is 1. They can be both positive. It can be both negative. Then when I think of how can I get the -3, I know the cross product. That's FOIL with the first L, then O and I means I cross multiply the two numbers. I use negative. Why I use negative? Because there is a negative sign right here. So only sum of, there will be a negative number involved in the addition. The sum will be negative. Two positive numbers, the sum can never be negative. So I try. So when I choose numbers, I always look for the largest possibility. So what is the most possible way? I just go for that. So 1, -1 times -1. Their product is 1. So 1 times 2, that's 2. Then -1 times -1, that's 1 here. Then what do? I check the cross product. 1 times -1, -1. 2 times -1, -2. Then when add those numbers together, -1 plus -2 equals -3. If this number is exact number before the middle term is exact coefficient of the middle term, -3 here, -3 here, then I can stop, which means I have found the 4 numbers. The first two numbers, the first row. Okay, remember this first, last, one first, one last. Go to the first binomials. 1 times A, well, we do not have to write 1 here. So write A here, and -1 means -1. So 1, -1 go to first binomial. And 2, -1. So the second row, go to the second binomial here. 2, all right, 2 here. 2 means 2 times a. Negative 1 means minus 1. So this trinomial now is factored into a minus 1 times 2a minus 1. And we do not write the coefficient 1 here because 1 times anything is still that thing. That is the case for when the leading coefficient is not 1 anymore. How do we deal with that? We need to look for 4 numbers, and one first, one last, another first, another last. They go to those 2 pairs, go to 2 binomials respectively. That's number 3. Okay, another factorization problem. Number 4 is a special factorization, which tests us. Do we remember if we see something squared minus another squared, capital A, capital B represent any monomial. Okay, it can be a number, it can be one letter, one variable, it can be some number followed by one or multiple variables. So as long as this polynomial can be seen as something squared minus another squared, we call this difference of squares. We can always factor it as sum of the 2 bases. So a plus b times difference of the 2 bases, a minus b. So remember, this is a very important special polynomial, difference of squares. How do we factor it? Sum times difference. Okay, for example, and so what we have here, we'll have 9y squared minus 100. What do we have? We have a binomial, and there is a minus here. And we also notice 100 equals 10 squared. And we see number 3, that's 9 squared. No, 9 is 3 squared. So the first term, if I rewrite it, I will say 9, that's 3 squared. We got the y here, so put 3 and y together, then raise the power 2. That's 9y squared, can be seen as 3y parenthesis squared minus, what is 100? 10 squared. See, we have something squared minus another squared. I'm going to put 2 bases. And the first base is 3y, add 10. 3y minus 10. Okay, that's the factorization for a binomial when it happens to be a difference of squares. This is what we are going to do. And so this first 4 problems, number 5, starting from number 5, we are going to work on what? Solving quadratic equation. Why we need to learn how to factor the polynomial? Because we can use it when we are solving a quadratic equation. And the typical one will be, okay, actually the problem on the final will be like this. So recall the 0 product rule. So if we have a product and like 3x plus 1 and times what? Times 5x minus 10, well, equals 0. So let's see if we have a quadratic equation, but the quadratic equation has been factored already. So this is what so if we have a product equals 0, what does that mean? It means either factor can be 0. So we'll let 3x plus 1 equals 0 or 5x minus 10 equals 0. Then solve each one. Both of them are linear equation. 3x plus 1 equals 0. How do we solve it? This is what we did in Algebra 1. So minus 1 on both sides. We got the 3x equals negative 1. Then what x is? X equals negative 1/3. Second one, 5x minus 10 equals 0. How do we solve it? Add 10 on both sides. So negative 10 is gone. We got the 5x equals 10. Then how can we get x? Divided by 5 on both sides. And 10 divided by 5, that's 2. So x equals negative 1/3 or x equals 2. So this is called what? Zero product rule. When we have a product equals 0, then any factor could be 0. There are two possibilities. And this is, okay, the number 5. Then number 6, things will get a little bit harder. When we are given a quadratic equation, nobody gives us the product. And the typical problem will be like this. We are given like x squared plus 5x equals 0. So this is a quadratic equation. Why quadratic? Because we have the square term. Okay, so to solve any quadratic equation, the best way is what? Write the quadratic equation in the standard form, which means we see 0 on the right. So move all non-zero terms to one side, and we see 0 on the other side. So this how we are going to use the zero product rule we just saw in number 5. So we have C0. Then factor the other side if possible. So we'll look at what is on the left side now. We see x squared plus 5x. Can we factor this polynomial? It happened to be a binomial. So to do the factorization, the first thing we do is what? Look for the GCF. Okay, so when we look at the x squared and 5x, do they have anything in common? Yes, both of them has x. So the x is the GCF. Factor the left side. We got the GCF times the parentheses. The leftover goes to the parentheses. So x squared, when we divide by x, the leftover is x. 5x divided by x, we got 5. And equals 0. So now we got what? We got a product equals 0. Then either the first one be 0 or the first factor. Don't forget that x itself is one factor. X equals 0 or x plus 5 equals 0. So there are two factors. Each one could be 0. Or x equals 0, nothing needs to be done. We know what x is. Equal x plus 5 equals 0, then we have to move on. We got x equals -5. So those are the two solutions or two rules for this quadratic equation. So again, to solve the quadratic equation, the best way is what? To factor the left side when we say 0 on the right side. If it is not factorable, then we are going to use what we learned in chapter 9. And so for any, so now I move things right here to solve the quadratic equation. You say, oh, Professor, I don't know how to factor this, or I forget how to factor this polynomial. Can I still solve this quadratic equation? The answer is yes. So remember, we had the quadratic formula when we have a typical quadratic equation written as ax squared plus bx plus c equals 0. So this is a general or standard form of the quadratic equation. ABC can be any number. Just a cannot be 0. If a is 0, that will not be a quadratic anymore. And so I write this down. A cannot be 0. Then the quadratic formula tells us x equals what? Equals 2 times a, that's the denominator. And numerator will be -b. So whatever the b is, we take the opposite, -b, either plus or minus square root of b squared minus 4ac. Okay, this is just in case on the final exam, if you are given a quadratic equation and you cannot factor the left side, you can always use this quadratic formula. Just plug A, B, and C into the formula. Simplify. Plus is one root, minus is another root. When b squared minus 4ac is less than 0, there will be no real solution. Okay, so this I bring everything together. How do we solve a quadratic equation? The best way is this. If we could factor ax squared plus bx plus c, that will be the best way. It will be the easiest and fastest way, because if we are going to simplify this radical expression, it will take us some time. Okay, that's number 6, solving a quadratic equation. That's basically what we did in chapter 6. Starting from number 7, we are going to move on to the rational expression. So the first problem, not the number 7, will be simplify the rational expression if we are given this, like 21 m to the third n squared over 28 m to the fifth n. Okay, what do we have here? We have a division, but we call this a rational expression. How do we simplify the rational expression? We are going to cancel the common factors. Say 21, and so always start with the coefficient. And there are multiple ways to do that, but I will just show you just one way here. You don't have to follow my way. Factor the coefficient. What is 21? 3 times 7, that's 21. Then we copy m to the third times n squared. What is 28? Do the prime factorization. 28 equals 2 times 2 times 7. And then times m to the fifth times n. So step 1, just work on the coefficient part. Now we are ready to do the cancellation. Just cancel the common number. I see 7 here, I see 7 here. So 7, 7 cross each other. And I see m here, I see m here, but they have different exponents. When we do the cancellation, we are going to keep the variable on the side which has a bigger exponent. So m to the third, m to the fifth. So m to the third will be gone. And I will still have the m on the bottom, on the side. Then the new exponent will be the bigger exponent minus the smaller exponent. 5 minus 3, that's 2. So m is crossed from the top because m has a bigger exponent on the bottom. And this new m now has the exponent of difference of the two exponents. 5 minus 3, that's 2. Then we see the n, which the n has a bigger number on the top. So then the bottom one will be completely removed or canceled or crossed. And the n on the top here, n stays on the top. The new exponent will be 2 minus 1, this 1. And 1, we don't have to write it. So do the cancellation, then rewrite the answer. Make sure you keep this clear as possible. I see 3 on the top. There is no m anymore because m is gone. I see n with the exponent to be 1. We don't have the right 1 here. What is on the bottom? 4 comes from 2 times 2. So 4 here. What else? I see m squared. This is the simplified rational expression when both the numerator and denominators are monomials. Okay, and another problem will be when the numerator and denominator are not monomials, they are polynomials. What can we do? For example, we have so please simplify this rational expression. We have what? We have x squared plus 8x plus 16 over what? Over x squared minus 16. Okay, we have a polynomial over another polynomial. For that one, you cannot cross those two x squared. I see 16. So can those just cross out? I have 8x left. No, we can only cross what? A factor. See, everything right here, they're multiplying each other. Only factors can be deleted, can be crossed. Okay, so if we have this one here, x squared is not a factor, it's one addend. So we'll treat the entire numerator as one thing, the entire denominator as another thing. They don't have anything in common for now, but let's try. If we break them down, look at the numerator. Trinomial, leading coefficient is 1. And then if it can be factored, it will be a product of two binomial. And when we look at the two binomial, we need two numbers. Product is 16, sum is 8. What are the two numbers? Can we think of any two numbers? Their product is 16, their sum is 8. 4 and 4. So 4 times 4 is 16. 4 plus 4, that's 8. So factor this, x plus 4 times x plus 4. Or if you recognize this is actually a special trinomial, which is a perfect square, because 16 equals 4 squared, and 8 is exactly equal to 2 times 4, and that will be x plus 4 squared. So that works as well. So multiple ways to look at the same problem. This is one way. Then move on to the denominator. What do we have here? Squared minus squared, because 16 equals 4 squared. Then how do we factor it? Sum times difference. X plus 4 times x minus 4. Then we compare, do we see anything in common? Any factor? Each parenthesis is a factor. I see x plus 4, x plus 4. Those two factors, they're identical. They cancel each other. And what is left? X plus 4 over x minus 4. That's it. We cannot continue. A very common mistake is, can I cross this x and this x? The answer is absolutely no. Why? Because those two x, they are not factors. They are addends. They cannot cancel each other. Final answer. This is another one. When we simplify the rational expression, if both the numerator and denominator are not monomial, they're polynomials, we will factor them respectively and then cancel the common factor. This is number 8. And number 9, we are going to look at a multiplication problem. And for example, what we have two rational expressions. We have a squared b over 3 okay, that's 1. Multiply by 15 to the third over, well, we have like 8ab squared. Okay, so this is what we are going to do. We are going to multiply those two rational expressions. How can we multiply? When we multiply two rational expressions, we'll draw a long bar. Like in class, I showed you, draw a long bar first, then use numerator times numerator. Numerator 1, a squared b times 15m to the third. And over what? Over denominator 1 times denominator 2. So just rewrite this expression as a 1 rational expression. What do we have now? We have one rational expression. We are going to simplify it. How do we simplify it? This is what we did in number 7. Cancel the common factors. I see 3 here and 15. I know 3 and 15, they have common factor 3. So, or you see 15 divided by 3, that's 5. Always work on the coefficient for number part first. 5 and 8, nothing in common, so that number part are down. Then we look at variables. I see A here. And this A has a smaller exponent, and this A has a bigger one. And then I have A on the top, and the 2 minus 1, that's 1. Exponent is 1. We don't have to write it. Then I see the variable B over B squared. this b has smaller exponent, it will be gone completely. On the bottom, I see I still have a b here, but then the exponent will be 2 minus 1, 1. And m, I have m to the third over m. So this m has smaller exponent, it's gone, and top one will give m, and 3 minus 1, that's 2. And of course, this expression is not pretty. We're going to rewrite it as 5 always. The number comes first, followed by the variable in order, in the alphabetical order. I see a here, I see m squared over 1 over 8. Always write down the number first, and then m is gone, a is gone, I have b left. Final answer. Okay, just be patient. You know how to do that. You just need to be very careful. On the final exam, even though there is time limit, but the time should be more than enough. So no rush. Take your time. Be patient. Go over the entire process step by step. Double check your work, then input your answer to my open math. This number 9. Multiply and then simplify. Then the other one, of course, will be what? Will be divide and simplify. And this time, I'm going to give you the rational expression when the numerator and denominator, they are not monomials anymore. They are polynomials. The same thing. Okay, see, I have m plus 2 over m plus 3. Okay, this is one rational expression. Divided by what? Divided by, let me make up the problem. M squared minus 4 over m squared plus 5x plus, no, m plus 6. Okay, see, we have a division problem. Divide. Rational expression 1 divided by another rational expression. And what do? Step 1. We never do the direct division for rational expression. We always turn the division into multiplication by flipping the second rational expression over. The first one remains the same. So take your time. This one turns into m plus 2 over m plus 3. The first one stayed the same, and then multiply. Divide turns into multiply, then flip the second one over. M squared plus 5m plus 6, go to the top. M squared minus 4, go to the bottom here. Okay, so just flip one, flip the second one, flip the divisor only. Now we have a what? A multiplication problem, which means I'm going to, rewrite this as a long bar to save time. Okay, I'm lazy here. Okay, write long bar and then numerator 1 times numerator 2. And then denominator 1 times denominator 2. Because each one, they have multiple terms, I'm going to keep the parentheses there. So then I have what? M plus 2 times m squared plus 5m plus 6 over m plus 3 times m squared minus 4. Now, how do we simplify this? We want to cancel the common factors. We have to make sure everyone is factored completely. Can I factor? So try, test every single parenthesis. Can we factor them respectively? M plus 2. That's prime. We cannot factor this. But for this trinomial, we can factor it as m plus 2 times x plus 3. Because 2 times 3 is 6. 2 plus 3, that's 5. Then I have m plus 3. This is prime. But then I have m squared minus 4. Square minus squared. 4 equals 2 squared. So factor this as m plus 2 times m minus 2. Then just use our IC. Can we see anything in common? I see m plus 2, m plus 2. There is another m plus 2. there is nothing to cancel 8 from the bottom. 8 has to stay. So one factor can only cancel another factor. 1 can only cancel 1. I see m plus 3, m plus 3. Those two cancel each other. What is left? M plus 2 over m minus 2. Okay, again, those two m's, they cannot cancel each other. This will be the final answer. Multiply and simplify. Divide and simplify. Okay. Then we have done addition. No, we have done multiplication, division. The next one will be what? Will be addition here. So when we do the addition, subtraction, they are the most challenging problem in Algebra 2, I believe, because when we see different denominators, we have to look for their least common denominator, so LCD or LCM, and make the denominator be the same. Then we can either add or subtract the numerators. And we have to keep the final answer to be simplified. Okay, so this is a general way here. Now let's look at the sample exam. The problem I gave you will be like this, or on the real exam. I have like a over a squared minus b squared at b over a squared minus b squared. So this is a relatively easier one. Why? Because we notice both of the two expressions, they have the same denominator. Okay, denominator 1 and 2, they're identical. Then that means those two expressions, they're ready to be added or subtracted. We are going to keep the common denominator, a squared minus b squared. Then we add the two numerators, a plus b. But then we cannot stop here. We'll have to ask ourselves, can we continue to simplify this rational expression? Can we? Try. The numerator is one binomial. It cannot be factored. So a plus b is a plus b. But the denominator can be factored because it is a typical difference of squared. So it can be factored as a plus b times a minus b. Now we see a plus b, they cancel each other. What is left? Nothing left on the top. We always put 1 here on the top. And then what is on the bottom? Let me move this. We have a minus b here. So 1 over a minus b, final answer. This problem tells us we should always make sure the final answer is simplified rational expression. How? Factor the numerator and denominator respectively, cancel the common factors. This is number 11. Number 12 is another typical problem. We call this simplify the complex rational expression. Okay, and this is number 12. And again, depending on what kind of rational expression we have here, the problem can be more complicated. So let me give you this one. So we have a rational expression. So first we have a bar here. And the numerator itself, it what? It is 1. So a minus b over a plus b. Okay, this is what? This is one rational expression, but this rational expression is above another bar. So the whole numerator is one rational expression over what? Over like a squared minus b squared over a plus 2b. Okay, see, that's what we have. We call this complex rational expression. To simplify this complex expression here, we notice that there is a easier way to do this. We can treat this problem as a division problem. So this one turns into, we can rewrite the numerator, a minus b over a plus b. Divide by, over means what? Divide by the denominator, a squared minus b squared over a plus 2b. Okay, so rewrite this complex rational expression as a division. Now we just, how do we work on division? We turn the division into multiplication times. Then flip the divisor over a plus 2b over a squared minus b squared. When we multiply, then we are going to keep a Lombard here, the numerator 1 times numerator 2, and denominator 1 times denominator 2. Okay, so we cannot stop here. So can we continue to simplify this? How? Check each parentheses. Can we factor any one of them? The answer is yes. So a minus b stays, and a plus 2b stays, because both of them are prime, and a plus b stays. But when we see a squared minus b squared, I can rewrite this as a plus b times a minus b. Then do the comparison. I say a minus b here, a minus b here. Those two cancel each other. Nothing else in common. Even those two are identical, but those two cannot cancel each other because they're on the same side. Only one factor in the numerator can cancel a factor in the denominator. If the two terms, they are on the same side, they're both in numerator or denominator, they cannot cancel each other. So the final answer will be what is left? A plus 2b on the top. On the bottom, we have a plus b times another a plus b. You can rewrite this as a square, a plus b squared. Final answer. This is called, treat this complex rational expression as a division here. And sometimes, let's see, we might see another, let's look at number 1, number 13. Okay, the rational expression might be, so this is by polynomial over polynomial. What if we have monomial over monomial? I'm gonna make this up here. I have 3 m squared over 5n squared over what? Over 18m to the 6 over like 15? No, over 25 n to the 4th. The big picture is 1 numerator over 1 denominator. Okay, treat this one as a division again, 3m squared over 5n squared divided by 18m to the 6 over 25n to the 4th. And again, we never do the division. We turn the division into multiplication, 3m squared over 5n squared. Multiply, turn the division into multiplication, and then flip the divisor over, 25n to the 4th, 18m to the 6th. Then for this multiplication, and we can rewrite this, just draw a Lombard, 3m squared times 25n to the 4th, n squared times 18m to the 6th. Then we just use, how can we simplify? Look at the coefficient first, 3 and 18. So 18 equals 3 times 6, so we have 6 left. 25 and 5, 25 divided by 5, we have 5 on the top. So this number part. For the same variable, I have m squared over m to the 4th. So now I'm going to write this down. 5, 6, I see m. So m has a bigger exponent on the bottom, so m will stay on the bottom. What is the new exponent? 6 and 2. 6 minus 2, that's 4. And for the n part here, I have n squared, n to the 4th, so n should stay on the top. Then the big exponent minus the smaller exponent, 2. Final answer. Okay, so this is number 13. We'll see 2 problems on the simplification of complex rational expression. Okay, And another problem, number 14, will be a problem about rational equations. So solve for rational equation. Okay, a simplest one will be like this. 3x plus 1 over x minus 2 equals 3/5. Okay, so how do we solve x? How do we solve x? Cross, so when we see a rational equation, and we have two rational term on each side, the cross product should be the same. So just cross multiply 3x plus 1 times 5 equals 3 times x minus 2. So do the cross multiplication. Cross product should be the same. Then remove the parentheses. 3x times 5, 15x. 1 times 5 is 5. So still use the distributive law. 5 times everywhere inside equals 3x minus 6. 3x, 3 times negative 2, negative 6. Then we see this is a typical linear equation. We're going to move all x term to one side. 15x minus 3x equals negative 6, this 5, negative 5. So we reorganize the terms, then combine like terms. 12x equals negative 11. Then what is x? X equals negative 11 over 12. This is a typical rational equation when there is only one variable. Then this only variable will be the unknown. We can solve it. If we get a rational number, we have to make sure this rational number is simplified. And negative 11, 12 is a simplified rational number, or we get this fractional number already, final answer. Sometimes, I bet you have seen this on the homework. When we are given a rational equation, there are more than one variables, and we are asked to solve for one of them. For example, so this time we are given x plus 3 over, y. I use y minus 2 equals what? Equals 1/2. I will see this is one, there are two letters there, x and y, and which one is the variable? The problem tells solve for y. So always read the problem. Okay, solve for y. There are two letters. Y, solve for y means y is the unknown, the variable here. Now, how can we do the same way? So for any rational equations, when we see two terms, one term on each side, just make sure their cross product be the same. And y minus 2 times 1, this y minus 2 times 1, still y minus, equals 2 times x plus 3. Because we are solving for y, that means y is the unknown. Eventually, I want to get y equals. And I have y minus 2 right here. So remove all the parentheses. Y minus 2 equals, and on the right side, so we have this cross product, 2 times x plus 3, 2x plus 6. To get y alone, what should we do? Add 2 on both sides. Then y will be on the left side by itself, because y equals what? On the right side, just combine like terms, 2x plus 8. Final answer, y equals 2x plus 8. That's the final answer. To solve for y, just make y on the left side by itself, and everything else, the x, the numbers, they all go to the right side. And so don't be afraid of when we see a rational equation, there are multiple variables, only one of them is the unknown, which means eventually we just make sure this unknown stays on one side by itself. Everything else go to the other side. This number 14, solve a rational equation here. And Number 15 will be a practical problem, which means it will be a word problem. We do not see the equation by ourselves, and we have to write down the equation by ourselves. So here comes a problem. It's like a ratio. So what we have here, so a girl is going to have a party, and she buys drinks for her guests. So this is her plan. So she is going to have like 7 gallons of water, so or drink. Okay, 7 gallons of Coke, for example, for have many guests, for like 14 guests here. So this what her plan is. And then turns out the day, on the day the party is going to have here, some people are not going to make it. So then there are only 10 guests shows up. And then she wants to have many gallons of the drink that she should prepare for like 10 guests now. So she does not want to waste, because not everybody can come here, and only 10 guests can make the party. How many gallons drink should she prepare? And how do we work on this problem? See, we know for this girl, when she prepares the party, she wants the drink that per people should be the same, no matter how many people are here. So the ratio of the gallons of drink per guest should be the same. So 7 gallons, that's for 14 guests. Now we have X gallons, that is for 10 guests. The ratio should be the same. Number of gallons of drink per people, 14 people, they in the 7, now they get 10 guests, how many? So keep the ratio be the same, and we get, this is called a proportion problem. How do we solve this equation now? Cross multiply. I got the 14 times x equals 7 times 10. 14x equals 70. What is x? X equals 70 divided by 14, 5. So which means she only needs 5 gallons of drink only. This is number 15, a word problem. Take your time, read the problem, convert the English phrase into one algebraic equation, then solve the equation, then answer the question. This is number 15 from chapter 7. Then the next one, we are going to move on to chapter 8, rational expressions. For any rational expression, we should keep the expression to be simplified form. So given one radical expression like this, please simplify this. Simplify like 48a squared b to the 5th. So please simplify this. When we simplify a radical expression, as we said before, we want to move things as much as possible out of the radical symbol. When we move things out, what the thing represents, it has to be a factor. So in another word, the more strictly saying should be, we should move the factors of the radicand out of the radical symbol as much as possible. So 48, this is, we can move 48 out, and we should use the factor tree. Let's say what 48 equal to. 48 equals 6 times 8. What is 6? 2 times 3. Prime. What is 8? 8 equals 2 times 4. And 4 equals 2 times 2. So it turns into, so 48 equals 2 times 2 times 2 times 2, then times 3. There are 4 2s, so 2 to the 4th times 3. That's 48. Then we got a squared, we got b to the 5th. So factor the coefficient first. Then when we move the factor out, what factor can be moved out? If the factor has one exponent being the even number. So if it has an even exponent, then this factor can be moved out completely. For example, what we see, 2 to the 4th. So 4 is an even number. So 2 can be moved out. And when we move this out, the exponent should be divided by 2. So 4 divided by 2, that's 2. What else can we move out? So we keep the radical symbol here. So 3 has to stay because its exponent is only 1. Then we have a squared. A squared, 2 is an even number. So 2, a can be moved out. We'll move a out. The exponent should be half of this. 1/2 of 2, that's 1. There is no 2 left. Then we see b. b to the 5th. 5 is an odd number. So, okay, so even number, I should make it stay here. But no number greater than 2 should be staying in the radical symbol. The number means exponent. So b to the 5th can actually be written as b times b to the 4th. So this b has to stay, but b to the 4th can be moved out. It turns b to the 2nd, and this b stays inside. Rewrite 8. 2 squared is 4. 4ab squared followed by square root of 3b. So make sure, how do we deal with the exponent? If it's an even number, this variable will be moved out completely. The new exponent will be half of the one inside. If this exponent is an odd number, is greater than 2, then we always write this as the variable itself times an even power of the exponent. So the number minus 1, that's what, okay, whatever we see here, that will be the variable times an even exponent of the variable. Then the even part can be moved out. B, the variable itself stays inside. Okay, this is number 16, simplify. And the other one, so what we have here, the radicand is a monomial. What if we have a polynomial inside? For example, if we, number 17, radical x squared plus 6x plus 9. You'll see, can I move the x out? Can I move the 3 out? Because 9 equals 3 squared, then I get x3. The answer is no, because none of them is a factor. We can only move factor out. But here there is, okay, this is a polynomial. What do we do? Factor radicand. X squared plus 6x plus 9, what does this equal to? If you recognize this is x plus 3 squared. Factor this. 3 times 3, 9. 3 plus 3, that's 6. It will be x plus 3 times another x plus 3. And x plus 3 times x plus 3 can be written as x plus 3 squared. Then can we now move things out? Yes, so x plus 3 will be moved out. Or you see square root of something squared equals the number itself. The radical symbol and square, those two are opposite operations. They cancel each other. Okay, either way can tell us the final answer is x plus 3. But sometimes when we have one radical symbol might be so. If I have x squared plus 36. Okay, can I factor this? The answer is no. That means nothing can be moved out. Even though 36 is 6 squared, x is x squared, they are not factors. So what the final answer? This is the tricky one. Okay, it stays because x squared plus 36 is prime. We cannot factor 8. Nothing can be moved out because neither one of them is a factor. So that will be the final answer. Okay, prime. The radicand is prime already. We cannot move things out. There's 17 and 18 here. Okay, so one more after I have given you the example already. Is simplify a big number, the radical big number, for example. Okay, here it comes. Please simplify square root of 343. When we see this number right here, so 343, how do I know what number can I move out? 343 is a big number. So it's the same thing as we deal with the 48 right here. We'll try to factor 343, use the factor tree. And let's see what the answer right here. Click on can we simplify this, factor this? 300, let's see, 11. Yes, okay, this is a very special one here. 343, if you break this down to a number, it equals 11 times 33, if I'm correct. 33, no, 11, 3, 33, 13, no, I'm wrong. So 343 looks like, what number? That's number pretty rare. Not a multiple of 2, not 3, not 4, 5, 6. Let's try 7. 343 divided by 7. 428. Oh, here comes. Okay, nice. This number is pretty rare. Okay, when I look at this number, I have no idea. How can I break this down? I just try. When I divide this by 7, 343 divided by 7, it equals 49. So this one is actually equal to square root of 7 times 7 times 7. Okay, 7 to the third. That's 343. Okay. Take your time. If you're given a big number, just try to break this down. Okay, 7 to the third. We know that we can see this as 7 times 7 squared. Then 7 squared will be able to move out. It eventually equals 7 square root of 7. Okay, I'll put a mark right here. So in case on the exam you see a big number, be patient. Try to factor that number. And after you factor this completely, you'll know what part can be moved out, what part has to stay inside. This is number 18. And the number 19. Okay, number 19, the problem will be like this. Simplify a mixed expression, like I have 3 minus radical 27 over 6. So when we look at this one here, first we see, well, this is one rational expression because we have a numerator, we have the bar here, and we have also the radical symbol. This can also be seen as a radical expression. So it's a mixed expression here. How do we simplify it? So we just always start with the radical symbol right here, radical 27. And can we simplify radical 27? 27 equals with 3, 9. And 9 equals 3 times 3. So 27 equals 3 times 3 times 3. And minus radical 3 to the third over 6. And 3 to the third, we know we can move 1 3 out. So 3 minus 3 radical 3. 3, 1, 3 stays. 3 squared can be moved out. Get 3 here and over 6. Now we look at this one as a rational expression. Can we simplify? Is there anything in common? We have 3 here, and 6 equals 2 times 3. So every term can be divided by 3. So this one is actually equal to 1 minus radical 3 over 2. That's the final answer. To simplify a mixed expression, it can be radical. It can be seen as radical. It is also irrational. So let's simplify the radical part. The key thing is what? The case we cannot have the radical symbol on the denominator. So we'll see a problem pretty soon. Then another one here. So number 20. So we're going to look at how can we add, subtract the radical expressions. For example, if we have this one, so 2 radical 2 plus square root of 32. Okay, so what do we have here? We have one addition problem. We want to add those 2 radical expressions. When we add or subtract the radical expressions, we are kind of doing the thing like combining like radical terms. The like radical terms means that they have the same radicands. For those 2 things here, apparently they are not alike because that is 2, that's 32. We cannot combine them now. To never combine the radicand like 2 plus 32, that's square root of 34, that's wrong. We can only combine the radical expression when they have the same radicand. If the radicands are not the same, we cannot combine them. But 32, we know this number can be factors. Can we simplify the radical 32? We know 32 equals what? 32 equals 2 times 16. Okay, and 16 equals 4. No, 4 times 4, and each 4, that's 2 times 2. So eventually 32 equals 2 to the 5th. That's 32. 1, 2, 3, 4, 5. 5 2s. That's factor trees. And 2 to the 5th can be simplified. Radical 2. And we know 5 is big number. We can treat this as 2 times 2 to the 4th. And 2 to the 4th can be moved out, get 2 to the 2nd. 2 to the 2nd, that's 4. Radical 2. So the problem turns into 2 radical 2 plus 4 times radical 2. Now, can we combine them? Radical 2, they're like terms. We'll just combine their coefficient. 2 plus 4, 6. 6 radical 2. This is one addition problem. Okay, we combine the like radical terms when they have the same coefficient. Number 21, the problem will be a very typical one called rationalize the denominator and then simplify. Okay, for example, what do we have here? We have 3 over 2 radical 2. This is one, so again, a mixed expression here. This is what I said. It can be seen as a rational expression. It can be seen as a radical expression. The thing that we don't like about this problem is the radical symbol is on the denominator. To get rid of the radical symbol from the denominator is called to rationalize. To rationalize the denominator means to get rid of the radical symbol from the denominator. How can we get rid of this? If we have a square of 8, then we can get rid of, so square a radical symbol, those two cancel each other. A equals A here. And to get rid of the radical 2, I need square. The square means what? I multiply it by another radical 2. Then radical 2 times radical 2 will be radical 2 squared. Then this radical sign will disappear. Whatever we do to the denominator, do the same thing to the numerator. The old numerator is 3 times radical 2 as well. Then simplify. The denominator is radical 2 times radical 2. Those two, that's 2. It's radical 2 squared. That is 2. 2 times 2, 4. Numerator, I got the 3 here, radical 2. So that will be the final answer. If you want, you can also write this as 3/4 radical 2. They are the same answer. Either way is correct. Okay, this is, so when we have the denominator as a monomial, which has a radical symbol and the monomial, what do? Multiply by itself, the radical part times itself, and do the same thing to the numerator. Then that's going to rationalize the rational expression. Sometimes, okay, I don't know if maybe, so sometimes you might see the radical symbol. So we have 2 plus radical 2. The denominator is not a monomial anymore. There are multiple terms. 2 plus radical. How can I get rid of this radical 2? We see we will multiply by the conjugate of the denominator. So 2 plus 2. What is its conjugate? So 2 plus 2 radical 2, and we turn the addition into subtraction. So 2 minus radical 2. That is called the conjugate of the denominator. Multiply by its own conjugate. Whatever we do to the new denominator, do the same thing to the numerator. 3 times 2 minus radical 2 as well. After we multiply the conjugate of the denominator, it turns into sum times difference. That will be square of the first one, so 2 squared minus radical 2 squared. Square of the first term minus square of the second term, sum times difference. And numerator stay the same. We don't work on this for now. Okay, so squared minus squared. Then the denominator turns into 4 minus 2. And numerator is like 3 times 2 minus radical 2. And simplify this, 4 minus 2 is 2. That's 2. And the numerator, you can just carry out the multiplication. 6 minus 3 square root of 2. Final answer. So that is a very special case when the denominator is a polynomial, especially it's a binomial. We are going to multiply the conjugate of the denominator on the numerator and denominator respectively. Then we can get rid of the radical symbol from the denominator. This is number 21. Rationalize. Both of those are called to rationalize the denominator. Then number 22 will be a radical equation here. So when we have equation, when see the variable, it stays inside of the radical symbol here. For example, I have radical x plus 2 equals 3. Okay, so when we have a radical equation like this, what do? We use the square method. We let the square term, let the radical term stay on one side by itself, like this one here. Then we square both sides. If we get a equals b, then we get a squared equals b squared. So this got the square rule. When we square a radical expression, we'll get a radicand. The left side turns into x plus 2 equals what? Equals 9. Then solve for this equation, x equals 7. And just remember, for both rational equation and the radical equations, we should always check the answer. Okay, after we get the final answer, can you always plug it back to the original equation? Then does the left side equal the right side or not? Because when we are using the square root, the perfect square rule, we might introduce some false solution to the equation here. When we have the final answer here, we have to double check, is the solution a real solution or not? This is one thing we should do for the radical equation. This is number 22. And number 23, we are going to move on to chapter 9. Okay, the problem will be like this. Given a function or given an equation in two variables. So we call this y equals x squared minus 2x minus 8. Okay, this is called an equation in two variables. Sometimes we also write this as function. M means function. Function f equals x squared minus 2x minus 8. So they mean the same thing. We can just use y to replace fx or fx replace y. And this is called a quadratic equation or quadratic function. And a typical quadratic equation in two variables will be like y equals a squared plus bx plus c. That is the standard form of a quadratic equation in two variables. No, sorry, not a squared, ax squared. Typo here, rewrite it, ax squared. We have a square term, we have a x term, we have the constant term. A, B, C are constants. That is called a quadratic equation in two variables. This is also called a quadratic function. And the thing we are going to work on this problem will be graphing this quadratic equation. What kind of graph will we get? We'll get a parabola. It either opens upward or downward. That is called a parabola. How do we know it opens up or downward? And it depends on what? It depends on the number a. When a is greater than 0, it opens upward. If it opens downward, that will be, a will be a negative number. Okay, and something else we should know here for any quadratic formula, and recall the recipes I gave you in class. How do we get x-intercept? We always let y be 0. So for x, we get x-intercept. And to look for the y-intercept, we always let x be 0. So plug x equals 0 to the equation, then we can get y-intercept. And also we need to know what is the axis of symmetry. So we know all these parabola, they can be folded in the middle, and the left side, right side, they'll match. Okay, so the axis of symmetry will always be a vertical line has equation of x equals negative b over 2a. And the turning point, either the lowest point or highest point, they are called the vertex. Okay, vertex, the turning point is called the vertex. And the vertex is always located on the axis of symmetry. And the symmetric line here is always on the, that's the turning point, is always on the line of symmetry. So the vertex is x and y coordinate. It's x equals always the x equals negative b over 2a, and then plug it into the equation and then solve for y. So those are the recipes I give you in class, and on the exam again. Okay, so you should apply this. For example, this problem asks us, consider this function. So the fx equals x squared minus 2x minus 8. And First, we'll see the direction of this is, so that this open upward or downward. Of course, it opens upward. So this first thing we should know. Then we are asked to get the y-intercept. To get the y-intercept, what do we do? Let x be 0. And plug x equals 0 to the equation here. What do we get? We get y equals 0 squared minus 2 times 0 minus 8. That equals 0 minus 0, the 0, 0 minus 8 equals negative 8. So, okay, this is the one thing I want to remind you here. Okay, so you'll see the y-intercept is 0, negative 8. If you are asked to input the point, or if the problem asks you just for y equals, just pay attention to what the problem asks. If the problem asks for y only, then y equals negative 8. If you ask y-intercept, you should put the number pair in the answer box. Okay, this x-intercept and this y-intercept. The x-intercept is what? Let y be 0. And y be 0 means x squared minus 2x minus 8 equals 0. That's y, or fx. Now what do? We go back to solving the quadratic equation. We see one side is 0, and then we factor the other side. Is this factorable? Yes, it can be factored as minus 4 plus 2 equals 0. Then x equals 4 or x equals negative 2. So let each one be 0. I get x equals 4 or x equals negative 2. So then you can answer the question. There are two x-intercepts, 4, 0, negative 2, 0. And what is the vertex? Okay, what do we do? Step 1. We solve for x. X equals negative b over 2a. What is a? A equals 1. So write down ABC first to be safe. For that equation here, for this equation, I write down a equals 1, b equals negative 2, c equals negative 8. That's ABC. Then plug a and b into b over 2a, negative. Negative, what is b? Negative 2. What is a? 1. It turns into negative. Always keep this negative sign here. B itself is negative again. Negative 2 over 2 times 1. Two negative signs cancel each other. It turns positive. So 2 over 2, that's 1. So x equals 1 now. Then plug x equals 1 into the equation. What is y? Y equals x squared minus 2x minus 8. Now x equals 1, 1 squared minus 2 times 1 minus 8 equals 1 minus 2 minus 8. That is negative 9. So, okay, we'll see the point of vertex is located at what? Parentheses, 1, comma, negative 9. So the vertex is a point. And any point should have two coordinates. This is x, this is y. Always solve for x first. X is always equal to negative b over 2a. This is number 23. And number 24 and 25 are two more solving the quadratic equations. And that will be, I mentioned this before. If you cannot factor 8, then you're going to use the quadratic formula. And that's where I gave you at the equation number 6. So given any quadratic equation like this, you can always use the quadratic formula. Just be prepared. Not all quadratic equations have solutions. When b squared minus 4ac is a negative number, there is no real solution. If it happened to be 0, then we have two same solution or just one solution. If b squared minus 4ac is a positive number, then we'll have two different solutions. Okay, so that's the final exam will look like 25 problems from chapter 6 till chapter 9.